Good morning, Algebra students. Mr. Belke back with another lesson for you today. Today we're looking at mixed expressions and complex fractions. That's lesson 11-8 found on page 620 in your books. So let's begin with mixed expressions. So if I have something like this, 3 plus 6 over x plus 3. All right, I can't add those together because they don't have a common denominator. The denominator here is really 1. Okay, so in order to add these numbers together, I need a common denominator here, which will be x plus 3, because I look at the least common multiple of those two, which would be x plus 3. So in order to get that common denominator, I have to do multiply the top and the bottom by x plus 3, because x plus 3 over x plus 3 is 1, and anytime you multiply by 1, it does not change the value. And that will give me x plus 3 as a denominator. So on top, I would have 3 times x plus 3 over x plus 3 plus 6 over x plus 3. Okay, so now that I have a common denominator, now I can add these guys together. 3 times x is 3x. 3 times 3 is 9, and then plus 6, and this is all over x plus 3. Now, the last thing I can do to simplify this is simply put like terms together, and that would be 9 plus 6, which is 15. So I have 3x plus 15 over x plus 3. And that's as simplified as I can make it. All right, next, simplifying complex fractions. So, for instance, if I had 8/3 divided by 7/5. 8/3 divided by 7/5, that's a complex fraction. Now, I could write this horizontally to make it a little bit easier to solve. So 8/3 divided by 7/5. That's what we have right here. Okay. Now, remember, dividing is the same as multiplying by the reciprocal. So I have 8/3 times the reciprocal, which would be 5/7. Okay. And then I can multiply, I can reduce, if any, which is not the case here. Then I multiply top times top, and I get 40 over 21. Okay. Now, let's take a look at example 3. If I have x squared, y squared, divided by a, divided by x squared y over a to the third. All right, now there's a complex fraction for you. But if we write this horizontally, x squared y squared over a divided by x squared y over a to the third. And remember, dividing is the same as multiplying by the reciprocal. So if I rewrite this as x squared y squared over a times a to the third over x squared y. Turn that into the reciprocal. Now I can look and see, what can I cancel out top and bottom? Well, here I can cancel out an x squared with an x squared. Here I can cancel out a y with one of these y's. Here I can cancel out this a with one of these a's, which would leave me with 2 a's, or a squared. And that's it. So on top, I'm left with a y and an a squared. Okay, so I can either write that as y a squared or a squared y. I'll go a squared y. And on the bottom, I am left with nothing. So it's a squared y over 1 or just a squared y for my answer. Okay, now let's put this all together and solve a complex fraction involving polynomials. Okay, so we're going to look at example 4. So here we have a minus 15 over a minus 2 over a plus 3, okay, or divided by a plus 3. So now first I'm just going to work in simplifying the numerator. And simplifying the numerator is similar to what I did right over here. Okay, so if I have a minus 15 over a minus 2, remember a is just like a over 1. And so to get a common denominator, I'm going to have to multiply top and bottom by a minus 2. Okay, so multiply by a minus 2, multiply by a minus 2. If I do that, I have a times a, which is a squared, minus a times negative 2 would be negative 2a minus 15, and that's all over a minus 2. Okay? And now I'm going to bring in this a plus 3. Okay? So this is going to be divided by a plus 3, which is the same if I wrote this horizontally as dividing by a plus 3. And dividing is the same as multiplying by the reciprocal. So I'm going to change this to multiply by the reciprocal, which would be 1 over a plus 3. Okay? Now, let's look at seeing what we can simplify out here. So here I have a trinomial. Do I have two numbers that I can multiply together to get 15, multiply together to get negative 15, add together to get negative 2? Oh, that would be negative 5 and positive 3. So if I have a plus 3, a minus 5 over a minus 2 times 1 over a plus 3. Okay? Now, is there anything I can reduce top and bottom? Sure enough, the a plus 3's will cancel out, and that'll leave me with a minus 5 times 1, which is a minus 5, over a minus 2 times 1, which is a minus 2. Totally simplified right there, and that's all there is to it. That's it for today. As always, if you have any questions, feel free to call, text, email, or you can join me online live between 9 and 10 o'clock. Have a fantastic day. We'll see you tomorrow.